right.
Somebody started a roll? Please do. All right. So, we've been talking about speed, right? Speed and motion in one dimension, right? So, let's do a quick exercise. And I guess it depends how quickly we proceed through this depends on how well you respond. So, let's start with a question or a statement, right? Calculate. Oh, that's weak. You might can't even see that on the board. All right, so let's start with a question. Calculate. Let's see if this red will come out better. Yeah. Calculate the speed. Oh, no. Sorry. The distance. The distance covered by light in 1 year. So that's the question. Calculate the distance covered by the speed of light in 1 year. So let's follow our problem-solving procedure, right? And what's the first step in our problem-solving procedure? What about it? Well, did I go over the problem-solving procedure in here? About the first step being identify the problem?
You said read the whole problem and make sure.
Yes, sir. Yes, sir. Right? So let's just quickly step back and let's just write those problem-solving steps down. Right? It's about 6 of them. One is, what's the first one?
The first one was read the whole problem and make sure you understand.
Right. Identify the problem. Right? What are they asking for? Identify the problem. 2 is what? Time scale. Right? What time scale do things occur on? 3 is givens. Those are presented, things that are given to you in the problem. It's called context clues, right? That's what we learned when we was in 5th grade, right? That's context clues. And then 4 is diagram. Sometimes we benefit greater from a diagram in certain situations than others. Okay? Sometimes we might not even need a diagram. It's just to help you understand, right? The 5th step is what? Physics. The equation. What's the equation? So oftentimes we jump to number 5, right? That's the first thing we want to do. The equation. What is the equation? Instead of having no understanding of the problem, we want to know what the equation is. And oftentimes we think about the wrong equation because we don't have a clear understanding of what the problem is asking for. That's why it's important you do these steps. And 6 is dimensional analysis. That's like checking your units, right? Dimensional analysis, right? So this is like a check to make sure you're doing things correctly, right? It's the ultimate way, foolproof method to check to make sure you have done your algebra correctly. It's with dimensional analysis. Check units. Check your units. right? And I hope that captured that on the video. If not, let me bag it up a little bit. Let me see. Oh yeah. All right. So, first step is to identify the problem. What's the problem here?
We need to calculate the distance.
Distance. So we'll write them right here, right? One is distance. And what unit are we using? Matter of fact, let's do a different color. Let's get a little fancy. Okay? Let's do a different color. So one here, still that weak green though. That green weak. Try the black. Yeah. All right. So distance, he said. And what was the unit for distance? Standard unit? Huh? Start with an M. Meters. Meters is the standard unit. Second step. What's the time scale here?
1 year.
We got years, right? Years, right? And just to move things forward, right? In order to calculate the distance covered in light by 1 year, what must we know?
We must know the speed.
The speed. So we must know that the speed of light is 3.0 times 10 to the 8 meters per second. So then that means we have another time scale. And that's what? Seconds. Yes. That's important. We must know that, right? You got to keep in mind that we have two different time scales here. So that means what? What does that mean? If we have two different time scales, then what does that mean?
We can do a conversion.
That means we're going to have to do some type of conversion in time. Yes, indeed. 3, givens. We got speed of light, c, 3.0 times 10 to the 8 meters per second. Right? That's c. And we have the time, which is in what? 1 year. Right? Fourth step is to do what? Draw a diagram. We don't need a diagram in this case. Fifth is the physics. What is the physics? What is the equation? What is the equation for speed? What is it? Distance divided by time. Speed is equal to distance, which we call x, and it's measured in meters, right? Let's say x, and it's measured in meters, divided by what? Time in seconds, right? Or it could be years or whatever. We're going to have to convert the times, right? So when I do my algebra here, I need to rearrange for what?
Distance.
The distance. So then that means what? X is going to be equal to what? Speed times the time. Right? And so now I'm just going to do what? I can plug and chug here, right? And S and C are the same thing. So let's change this to S so we don't get confused later on in our notes. If we go back and study our notes. A lot of people just write notes just to write notes and never go back and look at them. They just come in here and write stuff down and never go back and look at it. All right? So now we rearranged everything here, so now we can do what? We can plug things in, right? 3.0 times 10 to the 8 meters per second. And time is 1 year, right? Now, what's wrong with that?
It's not accepted.
So what must be done? Convert what? Convert the years to seconds. Let's do it up here. 1 year. What is it? I'm listening. Huh? 365 days. 1 year. What? Huh? 1 day is 24 hours. And then 1 hour is 60 minutes. And then 1 minute is 60 seconds. So what's this number at the top?
Three point one
3.15
five times 10 to the 7.
times 10 to the 7. Right? We need everything in scientific, right? What?
Second.
Seconds. So instead of 1 year here, we're going to put what? 3.15 times 10 to the 7 seconds. Now what? What's that number? So we at step 5.
I get 9.45 e to the 15.
Yes. What? What's the unit?
Meters.
Meters. 9.45 times 10 to the 15 meters. Now to you and I, we can't wrap our minds around that number. We can't think of how far that is because we don't have a good idea of how far a meter is. Or we do, but we kind of don't. So, what I want you to do is take out a sheet of paper and I want you to convert this number here to miles, okay? And you cannot use 1 mile to kilometers, which you found on Mr. Google Manual. Okay? If you use 1 mile is 1.609 kilometers, then I'm going to say no, give it back to you. And hand that in to me when we're done with it. And we still got that roll circulating, right? I think we got 13 registered. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, we got 13 registered on master. convert 9.45 times 10 to the 15 meters to miles.
Yes, that's the same.
Oh. No.
And use the T-chart like this. I need to see this. Yeah, you can use your notes. So if you took notes, go back through your notes.
What the word 9.45 to 15 meters to,
You say what?
what we trying to convert it to?
Miles. Hello? Yeah, but I can talk. No. Yeah. Yeah. Well, if we fly out of New Orleans, then we should probably stay there overnight. Cause especially with the guy in the wheelchair. You know what I mean? Cause that definitely, cause I'm a word, I'm gonna pull my hair out if I'm not in New Orleans the night before, especially if we're leaving in the early morning, and me and the students not in New Orleans. Yeah, we gotta stay there overnight. We definitely can't round people up early in the morning on campus and then drive up there. Oh hell no. Yeah. So yeah. Or yeah. Uh yeah, no. Yeah. It's gonna be good. It's gonna be me, Jamaica, so Layla. That's four. So of course, so Layla guess I have to rent a car myself. I can't rent no car and have students. We good. Class, we done. Right, I don't have a truck. Yeah, then I got a real truck with no cab. Yeah, a single cab truck. Yeah. Yeah. Me and the missus. Huh? Yeah. You say I gotta pay for my airline ticket? Okay. Okay. Yeah. Yeah. Mhm. You got a calculator problem. Yeah. Well, I mean, yeah. I mean, we ain't got no stipulations yet. Well, no. I'm saying, what you mean we ain't got no windows to play with? What you mean? Oh, okay. I was about to say. Oh, nope. You almost got away. You didn't hear me. I said if you use 1 kilometer and 1.609, I don't want it. I want it the way we've been doing it in class. Okay? So what that and the reason why is the reason why I do that. Okay? Because a lot of people what they do is they go and ask Mr. Google Man for a conversion factor. And anybody can do that. This is why I said you must show me this and no 1.069 because that's one step. Now following what I'm saying? No conversion between kilometer, yeah, and mile. Because that's one step. That doesn't train you on how to use the T-chart. And that's what the point of this exercise is. Because I've been going over this for 2-3 weeks now, and what I just realized is that a lot of people, they, like I said, they just come here and they write things down, and they never even go and look at what they wrote down. They never even go and look at what they wrote down. What did you do wrong?
I think it was just the calculator. Yeah, calculator.
I said my mama said my pants was too big. My pants too big? No?
Straight.
Yeah. That's what I said. That's what I'm talking about. Huh? So I record, right? So you can go back, look at the video, and you can follow exactly what I do. Exactly. Just like when you want to figure out any other thing, you go on YouTube and you search for it. You look at a video and you follow what that person in the video is doing. Not always correct, 100% of the time, but it's pretty good. Most people on YouTube are pretty good. Most people don't get on YouTube claiming to be something that they ain't. Most people. Huh? Now this one up here is 1 year to seconds, right? We're converting miles to meters to miles. Okay? But the T chart is the same, right? The concept of the T chart. Of course, it's going to have different numbers in it, but it's the same thing. So what you need to do is set the T chart up first, right? If you set the T chart up correctly, then it's just a matter of multiplication and division. You got to set the T chart up correctly. And you got to make sure units cancel out like I've been showing y'all. Okay? Now, if you're not clear on some units, you can ask me for units, right? 100 centimeters in 1 meter. 1 inch is 2.54 centimeters. I'll give you everything you need, okay? But you got to show me the T chart. That's the understanding, okay? $5,280 feet in 1 mile. So like I said, y'all, right? Conversions lie at the bedrock of science. Okay? So we gotta get this right, y'all. Because you're gonna be doing this the rest of your time here. I guarantee you. Every science class you take is gonna start with conversions. I mean general science. 2.54 centimeters in an inch. And everybody's registered in mastering, right? So when I'm gonna put some practice up for us. So. And so every now and then we're gonna break up class and we're gonna do this. We're gonna solve some problems. Okay? We're gonna do this every week. All right, we got 13 more minutes, y'all. And I'm gonna say, whatever you do in my class, don't give up. If you give up, then I can't do nothing for you. If you give up.
I thought Philly was pay for that.
You did what?
I had Philly better give me this.
Nope, that's right.
Wait, let me take a picture so I can remember how to do it. Okay.
Units.
Oh, no. I was just trying to right now.
Where you got that conversion factor? Can you look that up?
No, I haven't done this shit.
All right, well, what you should do is, you see this one? Look at this one. Right?
Mm-hmm.
So all of these are like typical conversions, right? This one's not so typical.
Mm-hmm.
So this is what I want you to get accustomed to using. That way I can track you more easily when you make conversions. So I can say, oh, this is where you went wrong, or this is where you did that wrong. Okay?
Yeah, that's just the way I've been taught. So, because I'm in physics too right now, so.
Yeah, but it doesn't matter the way you've been taught.
I know that's just what I'm used to, so that's how I did it.
Okay? Again, it does not matter what you're used to. I'm telling you how to do it. If you don't do it that way, you're not gonna pass. Okay? I hate to be that aggressive like that.
No, I'm perfect.
All right, that's why I'm telling you.
Cool with it.
Yeah, that's why I showed. That's why I took the time to show it to you.
Yeah.
All right? Cannot do it your way. This is not how that works. You don't do your things your way. Okay? So,
You got the round.
huh?
The round. That's it.
Yes.
Oh, no, it's
No, the number's wrong.
All of them?
Yeah, this number's wrong right here. Hmm? We're converting this number, and y'all got like 9 minutes to convert this number to miles. You got this right. You just not this. Well, no. This is how many centimeters on 1 meter? 100. Right? You got 1,000 centimeter to inch, inch to foot, foot to. You got feet. You got another. You got one more. You're not following the T chart? Remember how we do the T chart?
Mm-hmm.
Mile, inch. Well, this centimeter, inch. So now you're at feet. You're not at miles.
So I couldn't do it like this?
Oh, I ain't see that. Sorry. So 5 point.
I still wrong though.
Yeah, you ain't got the what's the name on there? It's a big number, right?
Yeah.
It's not. You got the number part right.
Oh yeah.
You follow me?
Yeah, that's right.
Yeah, you got to write it in scientific notation. How we doing? So you struggling? Yeah. Yeah, that's what you do in physics. Yes, indeed. Yes, indeed. They're gonna make you stronger, though.
So we gonna multiply 9.45 times 10 to the 15th power?
Huh? That's all one number, bro. This is a scientific notation.
Right.
You understand what scientific notation means?
Yeah.
Right? So this is all one number. You got me on that?
Yeah, I got you.
So what's your question again?
So then I thought we was multiplying. So 10 to the 15th power times 9.45.
No. That's all one number. Instead of me writing 15 zeros, I wrote 10 to the times 10 to the 15.
Gotcha.
Got me?
Yeah.
Yeah, so just like I was telling them earlier, right? So we're gonna do this once a week. Right? We're gonna break up. We're gonna have a day where we do lecture, a day where we have some well, maybe 2 days. We might do 2 days out the week. Maybe we need another day. And there's a certain way things have to be done. All right? You cannot go submit your taxes to the IRS and tell the IRS man, oh, I'm doing it this way because I was taught to do it this way. You can't do that. Or you can do that, but you might not get a return.
I think I fixed it
Is it 10 or is it? I think you got the exponent wrong. I think it's 12. Yeah, it should be 12. It should be 5.87 times 10 to the 12. See, you probably ain't, that's probably where you, see where you changed from right here? You probably ain't redo the calculation right. Because you had too many zeros there.
It's 15 for the start.
And what was the calculation?
For what, the beginning?
Yeah, let me see it. I can't see it here.
9.45.
You did you divided 2, no sir.
What?
No sir, You can't do that, man. You can't, you see what you did there? You violated so many laws of
I
mathematics.
thought you were supposed to,
You're supposed to multiply
Multiply
all
first.
the way across the top,
and then close parentheses, divide, and then
all the way across the bottom.
I didn't
Look
do
what you did.
so the ending was
You put, first of all, well, that is what you did, but you put 254. It's not 254, it's what? 1 inch is 2.54 centimeters. So there go your 2 orders of magnitude right there. Right? It's all good. It's details, baby. It's details. That's what we're here for. We gotta get the detail, knock the rust off and pay attention to details. By the end of the semester, that's what we're gonna be doing.
Who?
Dr. Stewart.
Dr. Stewart.
Let me get it right.
Yeah, get it right.
Please.
That's not a conversion that we do. 3.28 feet, that's not, I don't know if y'all do that if you in the same physics 2 class as her, but in my class, I ain't never heard of that conversion. Okay? So, I've been doing videos on these conversions for 3 weeks now. Am I right or am I wrong? Okay. And I have not used that conversion factor one time. Because I don't know it. I've never seen it.
I just got one from my other notes that we did.
Well, that's from your other class.
No, this from your.
No, you ain't never seen that conversion in my class.
That's right. You right.
Yeah, I know I'm right. Because I don't use that.
This lab teacher told me this.
You know what I'm saying? It's be arguing me down, boy. Tell me what I use.
You right.
I'm telling you. Come on, where you going? Let's get it together. Y'all something. Come on. It's meters. Now what? You say what? 1 meter, yeah. And what's at the top? What's at the top? You get in this too if you don't understand.
She wanted meters to centimeters. Yeah, you could convert that.
Yeah. How about y'all all?
And then I did
Yeah. I'm gonna sit here and let y'all work together and see. Yeah, he already got his. No. Y'all three right here gonna work together. He already got his. He gonna submit his and he out of here.
But I don't know how to do it on this one. I just got this one. Is this right though?
Oh, well, he only he got 500.
Yeah, that's right.
Okay.
But this don't have no unit on it.
Oh, my bad. Meters. Miles.
So wait, show me how you do that.
I honestly went off my notes from the other day.
I'm looking at my notes.
I probably done did it in class so many times.
When we did this one,
But y'all don't want to hear me though.
I just didn't do miles per hour. I just followed. We didn't do seconds. We just want miles.
Yes, sir.
When we did 100 meters to miles
Right
per
here?
hour. Yeah.
No, this 100 miles from millimeters.
Probably.
Right here,
Oh,
sir.
not mine. If you talking to me.
So
And I just stopped at. What did I do?
2.4 centimeters.
You want this?
Oh yeah.
Yeah.
Centimeters to inches.
I can't explain it, but that's what I did.
You can't explain what? What
I
can't you explain?
Like, if I didn't have this, I don't think I would know. I know I wouldn't know, like, what would go on top and bottom. Like, centimeters, inches, I don't think I would know the correct order.
Right. So that's what I'm saying, right? So when y'all in class, what y'all doing is y'all just writing, and y'all not paying attention. Cause I'm telling you, I do this purposely. All right. I purposely don't write what's on top.
I don't know if it's in the right.
Am I right?
I just got it.
What?
Don't I ask y'all what's on top and what's on bottom?
You do, but I'm just scared to ask questions. I don't like asking questions.
No, you can't do that,
I
man.
don't.
No,
Can you make sure?
can't do that.
Yeah, I just got it. So I don't know how to
She
work
don't
on
know
it.
what to put it on.
She don't know what to do. What?
I just got this one. I used to use the smaller one, so I don't know if it's in the right mode yet.
Okay. Mode. Yep. Scientific.
Mhm.
Yep. Degrees. Yeah, you right.
Okay.
Quit. Yeah, you good.
Okay, let me try.
And use parentheses. So the one that goes on the bottom, right, it has to cancel out with this one or this one. That's why it goes on the bottom. So it can cancel. If it's not on the bottom, then it won't cancel. You saying right, or do you really understand why it won't
I
cancel?
know why it won't cancel, but I just think in my mind, like, I wouldn't know, I guess, from meters to go to centimeters. You know what I mean? Like,
Well,
as
that's a matter of practice, though.
Okay.
That's when you do this enough, you'll know. It'll be in your head like, okay, well, I need to get to. First of all, I know that I'm starting with meters and I need to get to miles, so I know I need to go from what? The English system to the metric system. So I know, what did I tell y'all? If I'm going from English to the metric system, which conversion am I looking for? Nope, I told y'all. See, that's what I'm saying, man. Y'all gotta start paying attention, man. I told y'all, I'm looking for this in every conversion.
The centimeter one?
Yes, 1 inch is 2.54 centimeters. I told y'all to commit that to memory. Yes.
It's 2.54 centimeters.
But let me stop talking like that, because I know some people get sensitive and they go
No,
report
I'm
me.
sensitive,
They
no.
go record.
No.
They record me
I ain't
and
recording.
go tell people I didn't hurt them and all kind of stuff.
You can't hurt my feelings.
But we all adults anyway. I mean, shit.
You know what I'm saying?
Yeah, I get what you said. People too sensitive these days.
But, I know that is.
Call me a bully in my own classroom.
Damn, they that mad?
Wait, so how you get these numbers? What you
She,
do?
We got
this
multiply
right
the
here
top,
top's 100.
multiply the bottom, and then divide.
So this one you got the 2. This a 19 or a 17?
That's it. That is a 19.
So 15, and then you multiply it by 100, right?
Yeah.
Yes.
So it's 2.
Yeah. And
Uh,
then that's why I added the 2.
yeah.
Okay, that's what I'm trying to make sure.
Yep.
I separated, I did the multiply the top first,
And
write
then
it
do
down,
the bottom.
multiply the
Yes.
bottom, write
And
it
then
down,
divide both
divide
of
both.
them.
Yes.
And then you just 19
But on
minus
that
5.
calculator, if you got parentheses, you ain't gotta do all that. You could just
Oh.
put parentheses and put all the top in,
Mhm.
close parentheses.
Okay,
Divide,
okay.
open parentheses, put all the bottom in,
Okay, let me-
close parentheses. See that? That's why I told y'all that's the best. This is the best one to have, the TI.
Yeah, that's what I got.
Yeah.
Alright, so you say 9.45.
You open parentheses. Oh, I gotta go catch Layla too. So yeah, yeah. We gotta hurry up. Yeah. I gotta go catch somebody at my lab at 12:50.
We finished though. We just.
Yeah, y'all give me the y'all
Oh,
turn
yeah,
it
round
in,
up.
'cause I gotta go.
You got problems on cursing.
It coming. They not up there yet, but they coming. But you don't have to wait for me. All right. There's more problems up there that you can solve